Now, when you have known all these important points, let's talk about making ray diagrams. To make ray diagram in case of either concave mirror or convex mirror, you will have to consider three very important rays. First of all, before talking about ray, let me make all those points important. One, this is center of curvature and half of it is focus. Similarly here, this is center of curvature and half of it would be focus. So I'll be making this as a focus for the convenience of diagram. Now, ray number 1 is the ray which is coming parallel to the principal axis. This is the ray number 1. This ray will always pass through focus. Now this is a concave mirror, so it is going to reflect ray like this, so ray will easily pass from the focus, right? This would be the focus. But in case of this, the mirror is convex in nature, so it is going to reflect in that direction, but the reflection would be such that the ray would appear to be coming from the focus. So that is how reflection takes place in ray number 1. The ray which is parallel to focus, parallel to principal axis will always pass through focus. Number 2, second ray is the ray which is incident at optical center or the pole or the vertex. The ray which is incident at optical center will get reflected in the same angle. Like this angle I will be equal to angle of reflection R. This is followed in everywhere. Second ray, whatever angle it came through, it will get reflected from the same angle. And lastly, the ray which is incident on or which is passing through center of curvature. Suppose this is the ray passing through center of curvature, this ray number, let us call ray number 3, this was ray number 2. Ray number 3 is passing through center of curvature. So this ray is going to get reflected back. This ray is going to retrace its position. So that is ray number 3. Here, the ray which was incident in this along center of curvature, it will get reflected back. So these three rays are true for not just mirrors but only lens. The only difference is in during ray diagrams of lens, the third ray which is the ray from the optical center and the reflection ray, they are taken into different considerations. So we'll discuss that when we'll be doing, in a short time we'll be doing the ray diagrams for spherical mirrors as well, or sorry, spherical lenses as well. Now considering just these two rays or any two rays out of the three rays, you can make the ray diagram. For example, I'll make a similar ray diagram using just two rays. One is this, taking a concave mirror, F and 2F. It's okay to call center of curvature as 2F. Reason being, because the focus was at half of center of curvature, so even if it is radius of curvature, you can take it like that. Now, suppose my object is here. Okay, ray number 1, I am taking the parallel one which will pass through the focus. Ray number 2, I am taking the optical center one which will reflect at the same angle. So this is how the rays which they are meeting at some point, that point will be the formation of image. Same is the case with convex mirror. In case of convex mirror, F, 2F, this is my mirror, object, straight ray should be parallel to focus or should be passing through focus like that, and the second ray it will be reflected back at the same angle. So both the rays which are this ray, this and this ray, if I extend them in virtual direction or opposite side, I'll get this to be the image. So see, the difference is in this case we got real image, whereas in this case we got virtual image, right? So these are the points you'll have to consider to make ray diagrams. First of all, I told you about this one, the ray which is coming parallel to principal axis, this will pass through focus. Ray number 2, the ray which is incident at pole will get reflected at the same angle following the law of reflection, angle I equal to R. And lastly, the ray which is passing through center of curvature will always retrace its path. It will be deflected back 180 degree. Now, this is a simple diagram which I was just making, that image formed by a convex mirror. Here they have made the this ray diagram using two rays. One is the parallel and the focus one, which I also took, whereas the second one is the ray passing through the optical center or the radius of curvature. Not the optical center, radius of curvature, that is center of curvature, right? So see, so that ray got reflected back. In my case, I took the ray from this optical center or the pole, which reflected back, and I still got the same position of image. So it shows that doesn't matter which of the two rays you are taking, take any two rays, you will get your ray diagrams right. So if the only thing right now matters is the position of object, where object is to be kept, and then accordingly there will be different positions of image. So let's revise a bit. For concave mirror, a spherical mirror is concave if it is bent to be concave side as respect to the observer. The red one is the ray which is coming parallel to the principal axis, right? It is passing through focus. The blue one passing through the center of curvature, it is reflecting back 180 degree, and the last one, there must be another ray which is, okay, they haven't taken that ray which is passing through the pole, right? But we can take. Now, position of image always depends on the position of object where it is placed, right? So these are the two convex mirror thing. Convex mirror has a convex surface towards the observer, and again the image is always virtual. But in case of concave, the image is larger, upright further, and the image is real, inverted, and smaller, closer to the mirror. So these are two basic difference between concave and convex mirror, right? Image here is virtual, upright. Upright means erect, whereas in that case the image is downwards, which is called inverted, right? Now, there is a reason that this thing, concave mirror and convex mirror, are also called converging mirror and diverging mirror. We know that rays which are coming from infinity are coming parallel to the principal axis. Now all those rays which are coming parallel to principal axis are getting diverted towards focus. So consider a big object which is placed at infinity. The image will be a point image which will be forming at focus. So it converged all the light rays towards focus. That is why it is called converging mirror. Whereas this one, all the rays which are coming from infinity, they are also passing through focus, but imaginarily, right? So that is also forming a point image, but in virtual image, but this time all the rays are diverted. So this is called a divergent mirror. Next, these are few locations where you can draw ray diagrams for concave mirror. We'll start from here. In this case, the object was placed. I'll write the position of object, the position of image, and size. We'll talk about these three things. I'm starting from this diagram. First one, the object is at infinity, right? So infinity, where will be the image forming? Image will be formed at focus. Whatever rays are coming from infinity will be parallel to principal axis, and hence they will get reflected towards focus. So image is at focus. Size is highly diminished. Highly diminished because the image is the point size of image, right? Go to the next one. We have brought object a bit closer towards 2f or center of curvature. So that means object is placed between infinity and 2f. What is 2f? I am referring to 2f as center of curvature, right? Twice the focus. So between 2f, object is placed between 2f and infinity and 2f. This time image got shifted a bit back. Image got shifted between f and 2f. So f and 2f. This time the size is still diminished but not highly diminished. So we'll write just diminished. Third case, when the image is, that last diagram, when the object is placed at center of curvature, that is 2f, image is also getting formed at 2f with an equal size. So now you can see the pattern what we are following. We are bringing object closer, image is getting farther, and the size is getting increased. This is a simple pattern. So in this case, what should happen in the fourth diagram? Without looking at diagram, if I try to write, I am bringing it further. So 2f to f, this will get a bit back 2f to infinity and the size should increase. So it will be enlarged. Now let's see the diagram. We brought the object between 2f and f, image got shifted further between 2f and infinity and the size got enlarged. So this means in that case, lastly fifth case, these are all the main concave mirror diagrams. Fifth case, we have placed it at focal length, so image will form at infinity, because all the rays always follows the law of reversibility. What is the law of reversibility of light? That light, if reflected 180 degree, will always retrace its path. So that ray which is going parallel to principal axis is passing through focus, and this ray which is at the pole, it is going parallel, it will go towards infinity, which is both of them are parallel. Now my point was, if a ray is coming parallel to principal axis, from infinity will pass through focus. That means if a ray is passing through focus, it will go to infinity. The principle of reversibility of light. So in that case, when object is placed at focus, image is getting formed at infinity, and what would be the size? Size, how do we make size of an image? These two rays are meeting here, that means this is the size. Suppose these two rays would have met here, size would have this much long, right? So the size depends on where the rays are actually meeting up. In that case, both the rays are tending towards infinity, that means they are not going to meet, so size would be highly enlarged. So these are all the ray formations or image formations for concave mirror. The only thing is, every time the image which has been formed is what? Real and inverted. Why real image? Okay, let's talk about difference between real and virtual image. What is real image? Real images are those images which can be actually obtained on a screen, whereas virtual images could not be obtained on a screen. For example, in the ray diagram 1, 2, 3, 4 and 5, wherever there is a position of image, place some screen, any type of screen at the position of image, you will find the image formed on the screen. So you got the image on the screen, that means it was real. When we stand in front of plane mirror, when we go out of our home, we get ready, and when we see a reflection in mirror, plane mirror we are talking about, which is placed at or which is hanging in our home, the image is getting formed behind the mirror. So just remove the mirror and try to place something behind the mirror. Even if it is a screen, you won't find any image on that screen, because that is a virtual image. That is the major difference, that real image can be obtained on a screen, virtual image could not be. So these are all real, plus they are all inverted, because real image is always inverted. That is a very key point. The last ray diagram shows we have brought the object from infinity to focus. What if I further place it closer to the mirror? That means it is a place between focus to pole. This time image position depends. It depends how close it is placed to pole. So I am not writing it down. The closer you will keep it from the pole, it will be more farther away. Plus, in anyhow, it has to be a virtual image, because the ray diagram is something like this. This was our object. This ray has to pass through focus, and second ray has to reflect back at equal angle. So when I'll extend both of these rays, I'll get image on the opposite side, that means virtual image, and it will always be enlarged, right? It will be always greater than the size of the image. But the position will depend on how closer it is placed with respect to pole, right? So the height or the magnification or the size would be enlarged definitely, but position we are not sure about. Position will depend where or how close the object has been placed. So I hope this has all cleared your ray diagram concepts and doubts. Let's see what else we can talk about. This is a use. We have been studying about convex and concave mirror from quite a while now. Now, where do we use convex mirror and concave mirror? This is a proper use of convex mirror. It is used at the curvature of roads where the next road is not visible. For example, I am taking a turn like this. Hope it is okay to remove this. You might have noted it down, and if you haven't yet, go back to the video, pause the video and note it down. Keep writing your notes side by side while you are viewing this lecture, because making your own notes is very important. it helps you to score very well. Now, suppose the road is like this, okay? There is a tall building or anything, and the road behind that road goes this way. The road behind the building goes like this way. So if I'm driving from this side, I'm going towards that side, I won't be able to see whatever vehicle is coming from this side, right? That is why, to avoid any mishappenings or collisions, a convex mirror like that is placed here. A very broad, big convex mirror. Reason is, due to its broader point of view or broader view, you can easily see whatever vehicle is coming from this side, and the same goes for this vehicle. So both the drivers can see each other and they can avoid a collision. This is a good use of convex mirror. Then we'll talk about where do we use concave mirror. Everybody has seen torches. So torch is made like what? It is made up of a small bulb, but bulb doesn't give away all the light. The light is reflected in front. Suppose this is the bulb which is going to glow in the torch. This whole light is reflected in front by concave mirror, and the same principle is used in the headlights of our car, where the light is reflected by using concave mirror. See this is a concave mirror thing, though it will look a bit parabolic. Now you guys are more educational enough to know why it looks parabolic, not properly concave. There is a reason. See, we know that rays which are coming from infinity, what we are discussing right now is, this is a use of concave mirror, but it is not looking concave to us, it is looking parabolic to us. We are discussing the same thing, why parabolic is taken instead of concave. Though from the beginning of time, when the vehicles were getting started to be used, we started using concave mirror only, but later on we shifted to parabolic mirror. There is a reason. Point is, we know that the rays which is coming from infinity will get reflected towards focus, right? That means if the bulb is placed at the focus, whatever rays are getting from it will reach towards infinity. So this is what we wanted from this whole system or this whole setup, that we place the bulb at the focus of the mirror and it will reflect all the light in front, right? Because these rays will go towards infinity. The problem is that this doesn't happen. Why? There's a small defect in mirrors as well as lens called spherical aberration. Now what is spherical aberration? Suppose this is our concave mirror. I'm making two type of rays. One is these rays and one are these rays. These rays are classified, or they are termed as paraxial rays and marginal rays. Paraxial rays are those rays which are very close to the axis or principal axis, whereas marginal rays are those rays which are very close to the margin of the margin of the mirror. Now what happens? According to theory, what should happen is, these rays should meet at focus, right? But what actually happens is, these rays do not meet at focus, they meet at a small distance apart. This defect is called spherical aberration, that is, the paraxial rays and marginal rays do not meet at focus, they meet at different points. That is why, and this defect is not present in case of parabola, because in parabola there is this focus, whatever light which is coming parallel, they will all meet at perfect focus. So instead of taking a concave mirror, if we take a parabolic mirror, it will do the job.